Today we are learning about trigonometric ratios. If we take a look at your vocab sheet, you can see that the definition of a trig ratio is a ratio of the lengths of two sides of a right triangle. I would like to point out that the word trigonometry is derived from the ancient Greek language and means measurement of triangles. So there are three basic trig ratios that we'll be learning about today. They are called sine, cosine, and tangent, and this video is going to focus on the sine ratio. So first, let's take a look at a right triangle. So triangle ABC, we will be focusing on angle A. Oh, excuse me as I move this around. So angle A, let me just mark that right here. So we want to label our side lengths in relationship to angle A. So first off, as always, we want to label our hypotenuse first. So segment AB, which is our longest segment in the triangle, it is also the segment across from our 90-degree angle. AB is considered our hypotenuse, so I'm going to abbreviate that as HYP. And again, like I just said before, we are going to focus on our side lengths in relation to angle A. So if we look at angle A, we want to find the opposite side length. So the opposite side length of angle A would be segment BC. So BC, we are going to mark it as opposite. We'll abbreviate that as OPP. And we want to look at now what side is adjacent to angle A. Well, that just leaves us with segment AC. So segment AC is adjacent to angle A. So we're going to abbreviate that as ADJ. So we want to talk about sine of A. That is the ratio we're talking about today. So sine, which we're going to abbreviate as just SIN, so not sin, it's called sine. So if we want to find sine of A, what we want to do is look at the opposite sides and the hypotenuse. And the relationship is going to be opposite over hypotenuse. So in this case, for this triangle, sine of A is going to equal the segment BC over AB. Again, that is opposite over hypotenuse. Let's just take a look at a different example and focus on a different angle. So in this triangle, we want to look at angle B. And we want to find what sine of B is. But first we have to find what our opposite and hypotenuse segments would be. So the side length that's opposite of angle B is going to be segment AC. So we can abbreviate that as OPP. And I should have done this first, but let's just backtrack. We want to mark our hypotenuse, which our hypotenuse is always the easiest one to find because it's our longest side length as well as opposite of our 90 degrees. So we're going to mark that as HYP. And for this problem, since we only need opposite and hypotenuse, we don't necessarily need to mark our segment BC, but just to stay consistent, let's mark it as adjacent because that is our adjacent side length. So in this case, we have sine of B equaling the segment AC, because that's our opposite side length, over AB, which is our hypotenuse. So again, opposite over hypotenuse. So usually we'll look at problems when they give us the measurements of our side lengths. So in triangle ABC, we have side lengths 7, 24, and 25, and they've marked angle C. So we want to find what sine of angle C would equal. And again, it's going to be opposite over hypotenuse. We just have to figure out which side lengths are our hypotenuse and our opposite. So in this case, sine of C would equal AB, because that's our opposite, over AC, which is our hypotenuse, which this is equal to 24 over 25. So 24 is the length of AB and 25 is the length of segment AC. So sine of C would equal 24 over 25. And again, just to review, when we're looking at sine of any angle, we want to take the opposite side over the hypotenuse. And so again, the relationship between angle and side lengths for this case would be sine equaling opposite over